Hi guys, today I'm going to show you how to use Azure to build an AI model for computer vision that will run inside of a Docker container. Now this is all brokered by the Azure Custom Vision service. And this service enables you to easily build AI models that you can deploy in a number of different contexts, including Docker containers. Now this is in line with what we've been talking about over the last several videos, where we've looked at how to install microK8s and we looked at how to connect Kubernetes up to Azure Arc. And this enables us to have centralized management of Kubernetes clusters that are running outside of an Azure data center. And so this allows us to deploy workloads from Azure. We can control a lot of the aspects of managing clusters from Azure. And one of those is deploying different kinds of services down to clusters. So if I can create an AI model on Azure, I should be able to deploy that same AI model to any cluster that is running off of Azure, be it in some kind of factory, maybe it's running on my network at my house, or maybe it's running on a standalone IoT device that isn't connected to any kind of local network. Regardless of the application, this is just one of the ways that you can use edge computing and one of the services that really shines in the context of edge computing. So today I just really want to look at the nuts and bolts of what it takes to build an AI model using the tools that are available from Microsoft. And then I'm going to show you how to use those models in a more practical way in a test environment, where I've got an environment with a camera that I'm going to then call an AI model running in a Docker container in a local context. So this will show you kind of all the pieces that we need to build an automation to deploy these things more automatically, but I'm going to do it more manually today because it's good to understand the manual process because it's rather involved. It's not hard, it's just a lot of steps that you kind of have to take into consideration whenever you're building out this AI model and then using it in a context that is going to be meaningful. So let's just go over to a slide real quick and look at the process itself, and then we'll get into the technical details of how all of this works using a lot of the code that I've written already, and then we'll show you that code in action. So the scenario that I'm going to do here is video surveillance. So I want to be able to detect people and vehicles. So to train AI, I need a lot of data, and for computer vision, I need a lot of images, and because that's the data that computer vision uses. Now, I could go about taking a bunch of images myself, or I could use a data set that already exists. I'm going to use a data set that already exists, and that is the COCO Image Set. And it's really just a bunch of images that contain people and objects in a lot of different settings. And it also contains a lot of the metadata associated with these images that will become important when we actually start preparing these images for training an AI model. Now, most of the work that goes into AI is actually preparing the data. So if you can find a data set that will work for your application, you can accelerate your process dramatically. And that's why I chose to use the COCO Image Set, because it is already available and I can use it for the purposes that I'm going to need. And I'll put a link in the video description down below where you can download this image set. Now, with the COCO Image Set, I can then take the images and the metadata, and I can put that into Azure's Custom Vision service. Now, the Custom Vision service allows you to either do this more manually through an app, or you can do it through an API. Now, the process of taking an image and then creating metadata is called tagging. Now, tagging is basically where you work with the images to figure out the objects in the images that you're interested in, and then tagging them with a category, essentially. So if I'm looking for people, I'm going to draw boxes around all of the people in my images, and then I'm going to tell the computer vision service that that is a person. Or I might be interested in detecting bicycles. So I'm going to draw a box around a bicycle, and I'm going to tell the computer vision that is a bicycle. And these bounding boxes along with the tags give me the metadata that I need to train my AI model. So if you have a lot of images, tagging each individual image can be very time consuming. That's again why you might want to use an image set, but using Custom Vision service, it has the ability to help you do that. It expedites it quite a bit because it's a very intuitive and easy to use tool for building an image set that would work for AI. So once you're done tagging your images, you take a subset of those images, maybe 80% or 70%, and use that subset to train the model with. And so it's basically going to look at your tags, and it's going to apply a neural network to your tagged images to look for features within the context of your bounded boxes that will be common to people or to bicycles. So for people, it'd be like things like heads or bodies or arms or legs. And for bicycles, it would be things like wheels or handlebars or frames, whatever it is that you might be looking for that are common features of a bicycle. And once the training algorithm runs against all the images in your data set, it produces a model. And that model is then used by a test algorithm that takes all of the images that you didn't use for training to test the veracity of the model. And so those images get fed into the model, and it produces a confidence score. And then it will take the results of the test and feed that back into the training algorithm again to refine the training algorithm, to hopefully produce a more accurate model through many iterations of this. So this process will continue for a given amount of time. Sometimes it can be quick if you have a small image set, or if you have a large image set, it could take several hours or maybe even days, depending on what you're trying to train for. So in the case of my training, I ended up spending about 6 or 7 hours training an AI model using the COCO Image Set. So I basically tagged a bunch of images using the API, using the metadata associated with the COCO Image Set. And I ended up with about 2,000 different images. And then I told Azure Custom Vision to train on those images, and it produced a model. And then after that model was done, I then was able to apply that model. So what you can do with that custom vision service is you can export the model into something like a Docker container. And so it's going to have the production model, that's just the actual output from the training, and then it's going to give you an API that you can call. And that API is just basically a endpoint that I can call from an application. That application, in my case, is going to be a camera. And so that camera is going to be running on something like a Raspberry Pi or something else that's going to take images. And then the images are going to be sent over to this API. And then that API is then going to try to detect objects inside the images that are being taken by the camera. And then that API will return the results back to my device or onto my edge, and it will say, I think that this is a person, or I think this is a bicycle or a vehicle, and then it will give a confidence score of the probability that it is a person, a bicycle, or a vehicle. So this is the process that we're going to look at today. So we're going to try to figure out how to upload our images into Custom Vision, what it takes to tag those, look at what it takes to train and test, and then we're going to take the model out of the Custom Vision service and create a Docker container that has an API with the model, and then we're going to hook up a camera to it to use that model in a local context without having to call out to Azure. So I'm here in the Azure portal, and I've got the Custom Vision already pulled up. To create one of these, it's actually really easy to do. Just type in Custom Vision, and you'll see a link for services, and you can create one right here. Now you can choose a subscription, and you create a resource group, or add it to an existing one. You put it in a region, give it a name, and you choose a tier for training and prediction. So I'm just mostly interested in training because that is what I'm going to be building. Prediction is where you apply the model, but since I'm going to be using this in a local Docker context, I don't need to apply it on Azure. So when you select a training tier, you want to select a tier that's going to work for yours. So this allows you to have 2 transactions per second and 2 projects. And this is just more limited, so it will take longer to train models and that kind of thing. But for my purposes, it's going to work just fine. So I'm going to select this particular one, and this will allow me to train a model that I can use for what I'm doing for demos. And you could also use it for some lighter loads if you want to use it for that. And then you review and create, and it creates your service. Now, the service will look like this right here. And the service is the Azure panel or plane right here that you see that gives you a lot of information about your service. And the two things that you're mostly going to be interested in is this endpoint and then also your keys that we'll be looking at in a few moments when we actually look at some code. But the thing that you want to start off with first is the custom vision portal right here. So you click on that to launch the custom vision portal, which is the app that you're going to be using. So after you created this service, then you want to create a project. Now, the project is pretty straightforward, but there's a couple things that you need to select right here to make sure that you get the right things checked. So the project name is just my demo or whatever you want to call it. And you can put a description in there. That's not necessary. You choose the service that you want to use, and you can choose between classification and object detection. Now, object detection is the one where you can detect objects in the context of an image, and classification is basically there to just allow you to have a classification of a single item in an image. So you can get more information about that. That is, the classification is tags the whole image, and object detection is looking for objects within an image. So this is for many things. This is for one thing. But in any case, the object detection is what I'm interested in for surveillance, because I might be looking at people and vehicles in the same image. So once you have that chosen, the next thing that you want to select is the domain. Now, general A1 is probably going to be the one that you would use for most anything that you want to run on Azure. However, if you want to make this available off of Azure, you choose one of these compact domains. And the compact domain is basically a domain that is a model that is portable. So it's small enough that you could put it on something like an IoT device or a phone or something like that, and it won't require a lot of specialized compute or lots of GPU power, whatever it might be using to run that model for it to run. So it can run on a CPU, for instance, or it can run on a phone CPU. So I'm going to choose General Compact, and then you can create the project. So once the project creates, it'll show up right here. Now, I've already created a project, and this is where you do all of your image tagging. Now, if you're using your images from a manual image set, you can upload those here by clicking Add Images, and you can basically just upload the images into the app right here, and they will show up just like these are right here. But once your images are uploaded, then you can go about tagging those images. So my images are already tagged, but the process of tagging those is basically this right here, where you can draw a box around something and then you assign a tag to it. I'm not going to add one to this because it's already been tagged, but you say if I wanted to detect buildings, I could draw a picture around that, and then I would have a tag. I could add a tag right here like building if I wanted to, and then add the tag, or I can use one of my existing tags already. And I'm going to delete this one because I don't need it, but I'm going to delete the tag, and I'm going to delete the label for that tag. But in any case, this is what it looks like when you're doing this. So this one has several things. It has a bus right here, and it has a person, and it's got some persons back there and a car right there, the tail end of a car. It's got a car back there. This one has, all buses. This one has people. Looks like it's got something right there that I could probably be a train car, but it didn't detect it as a bus. But this is picking up these as persons right here. This one is detecting a bus, but I'm not even sure that's actually right. This one is picking up persons and bicycle, and there's a bus in the background right there, and the reflection. This one's got a bunch of persons in it. So you can see that it's got a lot of different tags associated with it. I guess I don't have any bicycle detection when I trained this model. I only trained it for persons, trucks, buses, and cars. I didn't add bicycles or motorcycles, but in any case, you can see that it has a rather rich set of images that are already tagged, and that way they're ready for training. Now, I imported these using the API, so I'm going to look at the code for that and show you what that looks like to show you the COCO Image Set, and then I'm going to show you the code that I used to import these using the API. So to show you what this looks like, the training data that I use for this is the image set, and there's also some metadata. This is the same image set that I pulled from, and you can see that it's just thousands of images of all different kinds that have different contexts associated with them. So the images alone are part of this, but there's another piece that's really kind of the linchpin of the whole thing, and that's the metadata. The metadata is an annotation file, as it's called, and the annotation file that I use is this one right here. And it's 450 megabytes of metadata associated with those images. And there's 100,000 images or more in that training data. I only took a subset of them. So it's about 20 gigs, if I'm not mistaken, of images. And then you have 450 megabytes of annotation data. I can't possibly use all of that due to the limitations of the service. So I'm just basically going to use a subset of it. And anyways, I'm not interested in all of the categories in that. I'm only interested in the ones that are going to be relevant to what I'm looking for. So to filter this, I basically wrote some scripts. Now, the training data looks like this. It's just a large JSON file, and it contains information about where this data came from and the licensing around it. And then it contains information about the images. Then it contains information about the bounding boxes, and then also the tags or the categories. And so this particular script right here is called extract2py. It's a Python script that reads in that large JSON file and then writes out a smaller one that's a subset of it. And so it's going to be looking for these categories. I didn't originally include bicycles and motorcycles, so that's why those don't exist in the trained model, but I could add those easily. And then I only want it to 500 images per category. So when you looked at mine in the portal, you saw that I had over 1,000 tags for people. And that's because some of the images that it found for like buses or bicycles or trucks had people in them as well. So I went ahead and added those into the tags for person. Now, in the most ideal circumstance, you have balanced data sets for each of your categories. So you want roughly the same number of images for each of your tags. However, in mine, that's just not the case, because some of these had multiple different tags in a single image, so it made them uneven. So it's going to be slightly more biased towards persons than it is some of my other categories. But if you can balance them, it's going to be a much better model. That's just one of the caveats of using this particular data set, though. So with that, this basically just reads that large image set and is producing an output right here. This is just a JSON object. And so info, licensing, images, about the image data, the annotations for it, and then of course the categories, which is your tags. And it's then just iterating over that, looking for images that match the criterion for the tags. And then if it finds a match, it adds it to the images. And then once everything is all said and done, it just writes it out to a JSON file. And once the JSON file is written, then it takes that same JSON file that's the output and it uploads that into Azure. And so that's where it's going to call the endpoint and use a key. Now, the key and endpoint can be found in the settings of your project. So if you come over here to your settings, clicking on the gear right here, you can see that you have the endpoint, you'll have the project ID, and the key, which is what you need to configure the API. So this is my endpoint right here. There's my endpoint, and then this is the project right here, and then this is the key. And that's what I need to call the API to upload the image. And so here, these are helper methods right here, but the basic flow for all this is pretty straightforward. It's basically going to go open up that metadata file that I created, that annotations file, and then it's going to go over each of the images. It's going to upload the image, and then it's going to look for annotations for that image, and then it's going to basically create the region, that is the bounding box for that region, and then it's going to tag that region once it creates it. And so it's doing some conversions right here in the code to basically convert from the format for a bounding box that the COCO Image Set uses to the format that the custom vision service uses. But in any case, it's just doing some conversion of all that, and then it uploads it. And once it uploads it, I am up and running inside of the custom vision service with this pre-tagged data set from COCO Images. So I'll link those in the video description down below, and I'll also put this code up on a GitHub repo if you're interested in it. I probably won't have it as of the publishing of this video, but once I automate this process, I'll put all that code into a GitHub repo that you can see in the video description down below as well. So whether you tag everything manually or you use the APIs like I did, once you're tagging is done, you can train the images. So the training is pretty straightforward. You can do a quick training or an advanced training. So I use the quick training is good if you just want to like get an idea of what it's going to be like when you do it. But if you want to get a more production oriented training, do an advanced training. And you can allocate a number of hours to the training. So I think I allocated about 8. And you can send me an email notification when it's done. And in most cases, it'll probably be finished before that. But what I did is I just basically say, train this, and I went to bed, and then the next morning I had a trained model. And so it can take a while depending on how large your image is. It's estimating a minimum budget of 1 hour, but you can allocate more to it. So I allocated 8 hours, and I think that was plenty to get a fairly decent model. And then you hit train, and that will then take you to the training screen. And this will then give you this right here, where you can pick the probability threshold and the overlap threshold. And these each have the minimum number of percentage of overlap between predicted bounding boxes and the ground truth boxes that are consisting in the prediction. So that's like how close do the predicted images overlap with the actual trained images. And then this one is the probability threshold, which is like the confidence score, where it says yay or nay for, oh, this is something or this isn't something. And so this one is training right here. Now I can I already started this training right here, and this one is training, but while I'm working on this one, I can use my old one that I trained a few days ago. And this one right here is my second iteration on this particular one. Now, while this one is training up here, this one right here I can actually use. And notice it's giving me image count warnings right here, where I have overlap between some of my tags. I have a lot more persons in my training data than I do buses, cars, and trucks, which creates some overlap in this. And this particular model is not real great. It's probably okay for what I'm doing, but you want this to be a high score right here. This is the overall effectiveness of the model. It's actually got fairly decent precision, but the recall is low, which basically is the number of, this number tells you the out of the tags, which should be predicted correctly, what percentage did the model actually correctly find, which is fairly low, but the ones it did find, it was able to do with high precision. So this is not a great model, but it's okay. I mean, I've seen better, I've seen worse. And this is the problem with general models, is sometimes you end up with something that's so broad that it's trying to do everything. If you have the luxury of training data that's going to be in a very specific confined context, say I wanted to put a camera to look at my driveway, and I built my image set from images from my driveway, I would get a very accurate model. But this one is taking images from all over the place and then trying to train on those, and that's why we're getting something like this. However, it's probably going to be okay for what I'm doing, so I'll just use it. And once you have your image trained, you can publish it, and this would be for the prediction API that is on Azure, or you can do what I'm interested in and export it. And notice what it allows you to do. So you have a lot of different options right here. You can use Core ML on iOS, for instance, if you want to embed this inside of a mobile app. You can use TensorFlow on Android if you want to embed this inside of a mobile app for Android. And of course, you have Onyx for Windows ML and ML.NET. And of course, you can use a Docker file, and this is going to use TensorFlow under the hood in this right here. Notice this is tagged for Azure IoT Edge, functions, and ML. You can also use this for anything that uses a Docker image or a Docker container. So I'm going to click on this one and export it. So you have an option to put it on ARM, like Raspberry Pi 3, Linux, or Windows. So I'm going to select Linux and then export it. And then it's going to basically just bundle the model with a bunch of pre-built code. And then I can click download. And this is going to give me a nice little package of everything that I need to build this with. So you can see that I have a couple of things right here that are useful for me. So the Docker file right here is an app that's basically going to expose an API, and the app itself is just an HTTP endpoint that I can call from outside the Docker container. And Azure ML is just some code that it uses to score this with, and then the Docker file is all the code that you need to build the container image. So show you what this looks like on mine. I have it already up in my particular environment right here. So if I go over here to not this particular drive right here, let's go to I think it's in my F drive, and source, no, it's my E drive. Drive. I have too many drives on this machine, and custom vision. And I have Linux right here, and this one is the data that I just showed you, but the app itself is code that was generated for me. I had to do nothing for that, and the Azure ML, I had to do nothing for this. Now, the Docker file, I did modify this a little bit, but otherwise it's pretty straightforward. The Docker file, it just, you can update some of these libraries because some of these are kind of old, but you could use a more current version of NumPy and TensorFlow and Protobuf right here, and get a more current version of that. But otherwise, it will build. And once you build this, it will then build a container image that you can use and deploy. So let's go over to my Linux context, and then I'm going to build this and then run it. So to build this, I'm going to use WSL2. So you can see that I have the folder that I was just looking at. So in WSL, you can go to the MNT folder, the mount folder, and then the drive letter. And then this is the path to the folder where I have all of those files, like the Docker file and the app and so on. So if I want to build this, it's fairly easy to do. I'm going to do sudo docker build, and then you can do a -tag, -t, custom -vision, and then you can do the Docker file, which is in the local folder. That's where it's going to look, and this one should build pretty quickly because it's not too heavy, but it's not exactly light either. But it's going to build this, and it's going to use pip to install the dependencies, and of course it's going to set up the app, and everything should work fine once this is done. And once it's done, I can deploy it. So I'll show you how to do that once this is done building. So to run this, it's pretty easy. You just run a Docker command. So I'm going to use sudo docker run, and then I'm going to do a port forward -p, and I can port 8081 to this, and then port 80 in the back end, which is the port the app runs on. And then you tell it what image you want to use, custom -vision, and that will start it in the background. Now, this one, of course, is going to tell me some things about you shouldn't run this because you're using Flask and so on. It's not intended for production, it's intended for dev. But in any case, this particular image is now running. Now, I already have the version that I want to run up already. So if I do sudo, and I do docker ps-a, and type in a password, of course, this is going to show me that I have one on port 8080 right here. And this particular one right here is already up and running. And this is the one I'm actually going to be using for what I'm going to show you here in just a second. So this is actually running on port 8080, so that's what I'm going to point to. Now, because this is running in WSL, I did a port forward from my NIC to this particular IP address in WSL so that I can get something into the back end of this. But other than that, if you're just running this in a Linux context, it should be fine. Now, the reason I did that is because the app I'm about to show you is basically using a camera on an external device. So the camera itself is running on another Linux device that I have attached to my camera, and the camera is going to take images, and then it's going to send them over to this to process them, and then it's going to do some of those bounding boxes around them and then do prediction. So let's go ahead and take a look at that code and see what it looks like. So I wrote this code in Node.js because this is a rewrite of a project that I'd previously done that used the computer vision API on Azure, but this is very similar to the custom vision service output. So rather than rewrite it from scratch, I just repurposed this to call out to the API provided by that Docker container that we just created rather than calling out to Azure. Now, to do that, it's basically wrapping around a project called Motion, which allows me to do motion detection. And Motion will do a motion detection and then take an image. And then this particular application will then be notified whenever that image is taken. And then it will then call out to the API with that image data. And then the API will evaluate the image and then do object detection on it and then send the results back. And then this will then take that image and then put the bounding boxes around it and then put a label on it to give you a confidence score as to what the object it detects actually is. And I could email that if I wanted to. I didn't do that for this particular demo right here, kind of commented that code out. But in any case, this particular one is the basis of the project for getting the image, sending it over to the API, and getting the results back and drawing some boxes around things that it detected. So with this, let's go ahead and run this and then take a look at what that looks like. So here is the images that I've downloaded, and here's one that I did yesterday. You can see I have my headphones on and so on. It's 100% person. I think I'm a person. And here's one that I just captured right here, and 98% sure that I'm a person. Here's one that says 99% as percent I'm a person, and so on. So it is able to capture all those images and then tag them appropriately with the AI model that we've used. So in this demo, we did a lot of different things. We took a bunch of images and we uploaded them to the computer vision service, and then we either tagged them manually or we tagged them through the API. I used the API. And then with those tagged images, we were able to train and test a model. And we do that for a while. We do that on multiple iterations to make the model better. And once the model is trained, we then exported the model and then built a Docker container to host that model in. And then we expose that model through an API. And then with that model running, we have a little app that takes images that are captured by motion detection and then sends them over to the model to evaluate those images and do predictions on them. So it will detect objects in those images that it's sending over. And then it sends the results back to whatever called it and puts a bounding box around it and labels it. Now, there's a lot of steps in this, and it's fairly straightforward, but it's not a simple task, so it takes a while to do all this. And if you had to do this manually every single time you updated your model, it could be rather arduous. So what I want to do in the next iteration of this is take this concept that we've talked about in this more manual test setup and put some automation around it. So do some DevOps with it. So we're going to be able to trigger a training and then have the training trigger the output and deploy the model. Then we'll build a container from that model. And then we'll deploy that container to a Kubernetes cluster. And then we'll have some actual devices running with cameras attached to them that are going to be using that Kubernetes cluster as an edge. And the edge will do something with the images, and then it will maybe notify me whenever it does an object detection. So this is what I'm going to attempt to do in the next video. So it's a completely different angle on what we're looking at here, but it will give you some more familiarity with how this might look in a production environment, or something that's going to be more project oriented rather than just some kind of manual demo that we saw today. So look for that video. It should be coming out in the next week or two as I work through some of those details. In any case, like and subscribe to the channel and pay attention to the videos for the GitHub repos where I'll release all this code and you can use it for whatever you so choose. And as always, thanks for watching and looking forward to seeing you on future videos.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.